Hello everybody, my name is Andrew Brown from the National Physical Laboratory in the UK, and today I'm going to give a presentation outlining the importance of traceability in the measurement of physical properties of airborne particles, and also give an example of how these are used in air quality monitoring networks across the UK. So I'll start briefly by introducing NPL and its air quality and aerosol metrology group. Then I'll go on to explain the concept of traceability and how this is realised in practice for particle measurements, and also describe how national measurement institutes ensure that measurements of airborne particles are comparable. I'll then talk through a brief case study about the measurement of particle number concentration at air quality network sites around the UK, before finishing by outlining some of NPL's current and future research interests in the field of airborne particles. So firstly, NPL is the UK's National Measurement Institute, which means that we are responsible for maintaining primary measurement standards and disseminating them to support industry and other end users. We're owned by the UK government and located in South West London. NPL has delivered air quality research since the 1980s, and recent growth in this key area resulted in an air quality and aerosol metrology group being formed last year. So regarding traceability, the principle of traceability is that any measurement result should be related to a reference through an unbroken chain of calibrations. And the definition on this slide here comes from the international vocabulary of metrology. Traceability to the SI is achieved through national measurement institutes via working standards and other calibration laboratories, as shown in the traceability pyramid on the left-hand side of this slide. And a very important principle here, which is the reason why a pyramid is shown to use this, is that measurement uncertainty increases as we go down the chain from the SI through to the final measurement. To give a practical example of this on the right-hand side, the measurement of vehicle emissions are performed by instruments in vehicle test stations. These are then calibrated using condensation particle counters in a lab, hopefully an accredited laboratory, and these may be calibrated using NPL or another NMI's CPCs. NPL CMCs are themselves calibrated against NPL's aerosol electrometers, which are in turn calibrated against the UK reference current source. This applies different voltages across the resistor to generate currents in the femtoamp range. And it's also important to mention that the implementation of CPC traceability is essentially method defined and is therefore validated through comparisons of electrometers and CPCs with other national measurement institutes. Which brings us nicely onto comparisons. National measurement institutes and some other reference laboratories undertake comparisons with their peer-reviewed laboratories in other countries. These are run under the auspices of Euromet in Europe or BIPM internationally, and performance in these comparisons can lead to internationally recognised measurement capabilities published in the publicly available BIPM key comparison database. And in the field of aerosol metrology, there have been 4 comparisons completed today as shown in this table. These cover a range of particle number concentrations, particle charge concentrations, and particle size distributions. And in general, at least after the first trial Euromet 1027 comparison, the level of challenge in these comparisons has increased over time. And the Euromet comparison plan for next year, Euromet 1480, is looking at particle number concentrations up to 500 particles per cubic centimetre, and this requires dilution to be applied to the particle stream before analysis. And this next slide just gives a flavour of some of the results from these comparisons, showing example data from Euromet 1027, which was done in 2009 on the left hand side, and Euromet 1282 from 2014 on the right hand side. And the horizontal red lines here are the comparison reference values, which is deemed to be the most likely result in the comparison. And there's a few things to note here. Firstly, there's a mixture of results in terms of both deviation from the reference value and the estimated uncertainties. This first comparison then had a number of results with no submitted uncertainties, emphasising the trial nature of this study. And you can see as you move from the first comparison to the second comparison, bearing in mind the different scale on the y-axis, there's a general improvement in results in the second comparison. And this emphasises one of the most important outcomes of these studies, which is to allow labs to identify issues with their measurement and to implement improvements to their measurement capabilities. So moving now on to a practical example of MPL's calibration of condensation particle counters. MPL operates the UK's particle concentration and numbers ambient air quality network for the Environment Agency, and reports the results from this network to the UK government's Department for Environment, Food and Rural Affairs. And the network consists of these 4 monitoring sites shown here at rural and urban locations around the UK, and it measures the components and the parameters shown here. And the case study I'm going to describe today involves the measurement of the particle number concentration at the Chilbolton, Honor Oak Park and Marylebone Road site using CPCs calibrated at MPL. So to give a bit more detail of this, measurements take place at Chilbolton in the south of England, and this site was moved from Harwell in 2016, and also 2 sites in London. Firstly at the Marylebone Road super site, and also at Honor Oak Park, and the Honor Oak Park site was moved from North Kensington in 2019. The instruments on the network are these CPCs here, which are commercially available instruments from TSI. So here's some example results showing the annual average particle number concentration measured at these sites from 2005 to last year. The blue line shown here is Marylebone Road, which is an urban roadside site, which enables the particle number concentration contribution due to traffic to be determined. This is a concentration above the Honor Oak Park line, which is an urban background site and shown in red here. And similarly, the difference between Honor Oak Park in red and the rural Chilbolton site, shown by the green line, demonstrates the urban particle number concentration contribution here. And this slide shows the annual average particle number concentrations at the London sites, with some legislative interventions overlaid. So if you look around here, 2007 and 2008, you can see that the introduction of sulphur-free fuels and the London low emission zone had a demonstrable impact on the measured particle number concentrations, which fall significantly. A much smaller fall can also be observed after the introduction of a more stringent low emission zone in 2012. And much more recently, an ultra low emission zone was introduced in London in 2019, but any effect on this will only be seen after collecting a few more years data. And an important thing to note here is that trends such as these can only be observed if the uncertainty of the measurement is smaller than the trend itself. This is going to be more challenging to observe as concentrations become smaller. And finally, this slide gives a flavour of MPL's current and planned research activities in the field of airborne particles. I'm not going to talk through all of these, but to pick out a few things, we are working towards making improvements to our calibration facilities, to better understand measurements of equivalent black carbon using accelerometers, and to move into emerging areas such as vehicle and exhaust emissions and particulate measurement in dental surgeries. And if you're interested in discussing any of these, feel free just to get in touch. And I also just wanted to flag extremely briefly a couple of things by my MPL colleagues this week. There's a talk by Christoph on Friday, and also a poster by Jordan on Friday. So to finish off then, to just summarise, ensuring traceability to the SI is essential when measuring the physical properties of airborne particles to ensure that measurements are robust and reliable. Traceability is achieved through a chain of calibrations to the SI via national measurement institutes, who ensure their comparability through regular participation in international comparisons. And ambient air quality data in London has shown a large decrease in measured particle number concentrations since 2005. These changes align with the introduction of cleaner fuels, cleaner vehicle fleets, and the introduction of low emissions zone regulations. And MPL is continuing to develop new approaches and calibration methods for the measurement of the physical properties and chemical composition of airborne particles. And finally, very many thanks to my colleagues at MPL, the people at NMIs and in other labs involved in Euromet and CCQM comparisons, Imperial College London for their work on the UK air quality networks and funding for the sources from the sources listed here. And of course, thank you very much for listening. And I'm now happy to take any questions.